Reminder, we are being recorded, but that doesn't mean don't ask good questions.
Watch your mouth.
Yeah, watch your mouth. And good morning. So this morning, folks, we're going to be doing variable speed training. Specifically, we're going to be getting into the variable speed air handler with a single stage setup. And so as I start to kind of open up the PowerPoint a little bit here, we'll get this all squared away. And again, Tony, I'll let you kind of be the monitor on that to make sure that the PowerPoint's streaming good and all that stuff.
Yep, everything looks looking good
as we come through this morning. Okay, team, so this morning in this overview, we're going to be discussing the low voltage wiring and setup of a variable speed air handler. And if you'll please follow along with me, we're going to discuss some of the key following points. A low voltage wiring and setup of a variable speed air handler, including the jumper selection of airflow settings and communicating terminals. Now, one of the things that we always like to remember with the variable speed product, it is communicating capable. Now, a lot of times we see the air handlers hooked up communicating, but a lot of times we see them hooked up on a conventional thermostat as well. Either way, it's going to work perfectly fine, and you'll still have all the variable speed functions available to you, even on a conventional 24-volt thermostat. However, when you do set these up, there are some things on the jumpers, specifically the airflow jumpers, that are going to be pretty important to talk about. As a matter of fact, a lot of times, you know, a contractor may take our air handler, just put it in, and just presume automatically that, for instance, a 3-ton air handler is set up for 3 tons of airflow. And the truth about it is, it might be set up for 3.5 tons of airflow, or 3.25 tons of airflow, or 1150 airflow, depending on where that jumper selection is. So we always recommend that during the startup and commissioning portion of the startup, that they double check these jumpers, and we're going to literally go over every jumper and every selection and how that works today. We're also going to talk about applying it with a single stage straight cooling equipment specifically, because we know that that's. Go ahead. Question?
No.
Okay. Because we know specifically that's a pretty strong market, and in some of our Florida markets and in southern Texas markets, we see a lot of cooling equipment with an air handler and just a heat strip for backup heat. So with all that said, let's take a look at that air handler control board. So if you were to remove the service panel and you were to remove all the harnessing off of the variable speed air handler control board, this is what you would see. Now, the reason we've done that is so that we can talk about all the features on the board. Now, please remember, guys, there's going to be harnesses at the very bottom of the board. You're going to notice there's going to be some harnesses that are going to be plugged in from the factory. And of course, it's all going to be plugged in with the air handler. The contractor doesn't have to plug everything up. It's already going to be pre-configured at the factory, as far as, you know, the harnessing and stuff like that. It'll have a fuse on the board and all that. And so we've removed those harnesses, or more specifically, we've chosen a picture without any harnesses on the board so that we can talk about all the features of the board. Any questions or comments so far? Okay, so starting at the left-hand side of the board, we're going to find that we've got some communication terminals. And we'll notice it's a 4-wire communication system. So you're going to have if you want to use a communicating thermostat, you know, one of our hex thermostats, it'll be 4 wires from the thermostat to the air handler, and then either 3 or 4 wires going outside based on the outdoor product that you've got. You'll also notice above those A, B, C, and D terminals, those hardwire terminals on the left-hand side, there's a service tool. And what that's for, you can actually plug a service tool in to access what we call the bus, or the communicating bus. And so all the information right there, the service tool, that A, B, C, and D on the service tool is identical. It's just a parallel circuit of the A, B, C, D terminals, the hard terminals, for service purposes.
Hey, Joel.
Yes.
How do we get our hands on the service tool?
You know, that's a good question. I think it's available with Source One. And in addition, if you take a look at your hex thermostat, I believe the hex thermostat comes with a little harness, and that harness should plug into that service tool area.
Okay, so they come in the hex. They come in the hex 3 box.
That sounds. I believe that's correct. So if you take a look at how that hooks up and configures, if you take that harness and you you plug it in, or, you pre-wire it basically onto the hex thermostat and plug that in. I believe that is correct. But that's a great question because I haven't had a hex thermostat box in my hands for years. So if you've got one in stock, maybe confirm that, Ty. That would be a good thing to do.
We got them at the office. I'll check.
Okay, yeah, but that's where you can plug a service tool in, and actually access that communicating bus for service purposes. So that's pretty cool.
And that works only if they have the Hex 3 hooked up, correct? It can't just plug it in, and it's got to have the Hex 3 on it, right?
Yeah, that's a good question. So basically, I guess what your question really is if I say I had it hooked up with a conventional thermostat, and I plugged a hex thermostat or I plugged a service tool on there, I mean, you could see that the board was functioning, but you wouldn't have the ability to operate the equipment if it was on a conventional thermostat. Now, if it's hooked up on a communicating system, there's a thermostat on the wall, a 4-wire communicating thermostat on the wall, comes down to this and then goes outside and it's all communicating, that's where you'd use that service tool. But the service tool is essentially useless if it's hooked up to a conventional thermostat.
All right. Okay.
Good questions. Excellent questions. Now, if you do go with a communicating system, you have some optional inputs on the board. And up there on that green bar up above, you can see that LAS, that leaving air sensor. That's an optional sensor that you can hook up to the board. And what that is, that's a leaving air sensor. And if you have a communicating system, we give you that capability of having a leaving air sensor on there to tie into that communicating system. So you can basically see a leaving air temperature on your thermostat if you have a communicating system. In addition, we give you a float switch that can be used with our communicating thermostat. And what that is basically if you have a float switch, or they call it a float switch, but it's an auxiliary alarm switch that you can hook up to that, and it will show an auxiliary alarm. Now, whether it's 24 volt or communicating, you have a HUME output. That HUME output's a 24 volt output to operate a humidifier. If you so desire, you want to run a humidifier. And so that's a 24 volt output, and that will be energized or enabled anytime you have a call for heat. Anytime you have a call for heating operation, you'll have that HUME output for a humidifier output 24 volt. Right next to him is an EAC output. This is for an electronic air cleaner. And the easy way to remember this, it's a 24 volt output, but anytime the fan is running, you'll have an EAC output to operate a 24 volt electronic air cleaner if you so desire it. Now, as you kind of move around the board a little bit, you're going to notice there's a green CFM light. That green CFM light, it's really more of a reporting feature. Now, let me say that again. Based on the airflow that you have set up on the board, it's going to report that airflow. So in other words, it's going to blink one time for every 100 CFM that the fan is blowing. So if you observe this light at any given time, whether it's on a heating call or a first stage call, second stage call, it doesn't matter. Whatever that blower is set up for, it's going to be reporting that CFM, and one flash of that light will equal 100 CFM. So you can sit here and actually watch it, and you can count the flashes. And it's just a really quick, easy way to confirm, that your airflow is set up the way you want it. And again, we'll be talking about the airflow jumpers here in a little bit. Any questions or comments? Go ahead.
Hey, just a quick question on the EAC ports there.
Yes.
Is that strictly for only electronic air cleaners, or could you wire up, like an iWave into that?
There would be no reason that you couldn't, as long as it's a because what that is, if you take a look at that little green bar where we see HUME EAC, you'll look right down below it. There's two little black relays, and those are isolation relays. So these are isolated 24 volt output. I believe the actual contacts themselves are good for up to 1 amp, and so so those outputs are isolated outputs. Yeah, so there's no reason you couldn't utilize that for some other function. and basically what you'd be doing is you'd be looking at anytime the fan is running, I'm going to have that output.
It has it inside. It's built in.
Good.
Yeah, I was just thinking if it was easier to hook the iWave up to the EAC port, or you just keep doing it the way it's always been, to the blower.
Well, so give me a little bit more information. So when you hook it up into the blower, are you just monitoring the blower, or are you actually taking power from the blower to power up your device?
I'm gonna let one of these guys answer it.
We're just commandeering some of the power to run the iWave.
Did you hear that?
Okay. All right. So and is that on the line voltage or the control voltage side of the motor?
The line voltage side.
Speak
Okay.
up.
Line voltage side.
All right. So it sounds like it's like 110 volt or a 220 volt device. Is that correct?
Yeah, 220.
220. Okay. All right. So if you're going to do something like that, what you'd want to do is you'd come off this EAC terminal, 24 volt, and you'd hit a pilot relay. You'd hit the coil of a pilot relay, and then anytime the EAC came on, you'd click that relay, and then you'd take power through that relay over to your device. So you could set it up as an isolation circuit. That way you wouldn't have to take power directly, from the motor terminals or whatever. So you could use it for that, but in this case, you'd have to have an isolation relay. You'd operate a relay with that EAC output, in other words. Good questions.
Just turn it on when you want.
Yeah.
That would be just a control voltage thing.
Yeah. All right.
Good. Excellent questions. Any other good questions or comments?
Everybody else is asleep.
Everybody good? Okay, right next to that CFM light, fellas, we have a status light. Now, this status light is going to flash off and on, and it should be noticed it's also utilized as a fault light. So if you do get a fault on the board, you can see that on the status light. And please note, it's a red light, but normal operation is it's going to flash 2 seconds on, 2 seconds off, 2 seconds on, 2 seconds off. So if you see this thing flashing, and I kind of wish they'd have made it a purple light or something, or a yellow light, but it's a red light. But just remember, normal operation is a flash of 2 second on, 2 second off.
So a fault would be solid on?
One more time. What was the question?
A fault would be solid on?
It could be. Look at your service information. It'll report different fault codes. Yeah. Good. So, fellas, right next to your status light, you have a heating jumper. And that heating jumper is one of 4 jumpers, and we're going to talk about these jumpers in a separate little session. But just to kind of show you where they are on the board for the time being, you've got a heating jumper. You've got a cooling airflow jumper. Now, please remember, the cooling airflow jumper works with the adjust jumper. Those 2 jumpers work together. You have a delay jumper, which we'll talk about here in a minute or two. And you have the adjust jumper. And again, please remember, cool and adjust, they work together to give you your cooling airflow. So when you set these air handlers up, fellas, you're going to be looking at your install information. And let me pull an example of some install information as we talk about those jumpers specifically. Now, guys, remember, we always ship our air handlers typically on the highest airflow that they're able to blow, only because we don't know what kind of duct system they're going on. So it's not unusual for us to always ship our air handlers on high airflow. But it's really important, once you establish your duct system, once you build your duct system, you're going to always want to make sure and design your duct system for 400 CFM per ton of cooling. So if you got a 3-ton unit sitting outside as an example, you're going to build a duct system to handle 1,200 CFM. If there's a 2-ton unit outside, 800 CFM, you can't get the idea. So we're always going to set up our airflow and design our duct system for 400 CFM per ton. When you're getting ready to commission your airflow on this air handler, a couple things you're going to want to do. So you're going to go to your install information, and as you can see, the airflow data that you see on the screen right now, this is just an example of the information in the install guide. So the first thing you're going to do, you're going to find the air handler size from the chart. As you can see, there's different air handler sizes. So find the proper air handler from the chart. Determine the desired airflow. Now, again, we always recommend 400 CFM per ton. So set your airflow up for 400 CFM per ton on a Y/Y2 call. Now, please note this, that when you're setting your jumper up, your jumpers, your airflow jumpers, you're actually setting up the high speed airflow. Because what will happen if you get, let's say you have a 2-stage unit and you get a Y1 call, first stage compressor operation. The control board will look at your cooling jumpers, your cool and adjust jumper, and then it will automatically take 65% of that jumper setting for a Y1 airflow. So what you're always setting up, just remember, the jumpers are actually configuring your Y/Y2 airflow. Once you do that, you're going to, step number 3, you're going to look to the left of the chart, and you'll see the jumper taps for cool and adjust on the left-hand side. And then one more time, please remember the jumpers you're actually setting up for Y or Y2 airflow, as your high-speed airflow. So let's do an example. Let's do 1 or 2 examples. So let's say, for instance, we see that we're looking at an AVC36B as an example. An AVC36B air handler. So we find the air handler on the chart. Then we go down where it says high. And we see that we want 1200 CFM. So let's say this is hooked up to a 3-ton unit outside. We want 1200 CFM. You move straight to the left, and you see that your cool tap is on A, and your adjust tap is on A. So whenever we set these air handlers up, we always want to remember before we walk away from the job to set up the airflow, the proper airflow based on the tonnage of the outdoor unit. Any questions or comments before we do another example?
Do they always default as an A on the A in this case, or?
No, not necessarily, because based on the air handler, we typically ship them on the highest airflow they'll blow because we don't know what kind of duct system they're going on.
Okay.
So if you look at the top line, it's YB. It will be set up.
Yeah. So let's do another example. Let's say, for instance,
tell me it down.
Yeah.
Let's say, for instance, you're looking at an AVC42 air handler. This the second example, and we need 1400 CFM, and on high airflow, and we look to the left, and we see that those are set up on B and B for the proper airflow, but from the factory, the highest airflow on that air handler is A and B. And that's probably where it's going to come from the factory. I'm just saying most of the time we ship them on the highest airflow they'll blow.
Yeah.
So it's really important that you set your airflow up because, guys, you may have a situation where you might have a 42 air handler. You might have this AVC 42 air handler on a 3-ton unit outside. Well, you don't want to keep it at 1500 CFM. You want to take it down to 1200 or close to 1200. And if you look down to the bottom of that chart in that AVC 42 air handler, if you look down towards the bottom, 1200 CFM would be like cool tap C and adjust A if you had this hooked up to a 3-ton unit. You see what I'm driving at?
Yeah.
So we always want to make double, triple sure, we're blowing the right airflow based on 400 CFM per ton, regardless of what air handler we have. Because as you can tell, there's a lot of airflow settings on these air handlers. And again, that example that I gave you, you might have a 3.5-ton air handler inside with a 3-ton unit setting outside. So we're going to have to adjust that airflow accordingly because you don't want to blow too much air, especially down in your market, because if you have too much air going across the coil, you're going to lose your humidity control. So it's real important to set that airflow up. Any other good questions or comments on the cooling airflow before we talk a little bit about heating and a few other subjects? Any questions or comments on setting this airflow up on cooling?
We don't need to hear none about heating.
Well, we're gonna show it to you anyway. So the heating airflow is pretty straightforward, guys. I know you guys probably put some little heat strip of some kind in your air handlers, in case it does get chilly. And so what you're going to do, you're going to find the air handler size from the chart, just like we did before. Step number 1. Step number 2, we're going to determine the desired airflow based on the heat kit size. So if you guys take a look at our air handlers, you're going to notice on the data plate of the air handler, on the data plate, it's going to tell you how much airflow is going to be required for every particular heat strip size. Once you determine that, you're going to go down. Step number 3, you're going to find the jumper tap on the left-hand side of the chart, just like you did before. And please remember, guys, the jumper configuration that you're setting up for heating airflow will be the high speed or the W2 heating. So let's do an example. Here we have an AVC 48. Here's a 4-ton air handler, and we take a look at the data plate on the front of this thing, and we say, okay, you know, I've got a 10 kW heater in there, or whatever it is, and it requires 1600 CFM or 1650 or whatever. And so we're going to grab the closest CFM that we can get to that recommendation, and then we're going to set that heating tap accordingly on the left-hand side. So in our example here, we needed 1650 CFM on that 4-ton air handler, and that ended up being heat tap number A. Heat tap number A. So our cool and adjust work together. Our heating airflow tap sets all by itself, A, B, C, or D. And again, based on the heat strip size will determine where we set that jumper. Any questions or comments on that, fellas?
I guess you're going to talk about the delay next. That's going to be what is the delay for?
We're gonna talk about that next. Okay, on that delay jumper, that great question. What's that delay jumper for? So this is one of 4 examples you're going to find in your install information. And so what the delay jumper does, the delay jumper has 4 selections for different cooling on delay functions. Now this on delay function is going to be determined by your local climate. And what I mean by that is this: if you're in a real humid environment, you're going to have a different delay setting. And what this is whenever the thermostat calls for cooling, it's going to run the fan for a certain amount of time at a lower airflow, and then it'll ramp up to another airflow and so on. And so the reason we do this, in this example, I'm showing you what we call the B profile, which is for humid environments. And again, look in your install information. There's 4 different profiles. I'm just giving you an example of one right now. This happens to be the humid profile, and I figured that'd be a pretty good example for you cats down in Florida. And so if you take a look at this humid profile, what it does is whenever you get a call for cooling operation from the thermostat, based on this delay jumper set on the B, in our example B for humid profile, what's going to happen, the fan's going to start up and it's going to take a 30 seconds to ramp up to 50% airflow. And then it's going to hold 50% airflow. Now remember, you've got the unit, you know, you got a 3-ton unit outside. So let's put this in perspective. Let's say we've got a 3-ton unit outside. It's going to ramp that fan up for 30 seconds and it's going to run at 1.5 tons of airflow with a 3-ton unit setting outside for 2 minutes, 50% airflow for 2 minutes. And what that's going to do is going to make that evaporator coil really cold really fast. And what that does is starts really pulling moisture out of the air. Because remember, the lower the airflow, the colder the evaporator, and the more moisture we remove over a period of time with a cold evaporator. Then after 2 minutes at 50% airflow in this example, it's going to ramp the fan up to 82% airflow, and it's going to hold that reduced airflow for 5 more minutes. So we're going to run that airflow up to 82% and hold it there for 5 more minutes. And again, that's going to start really helping pull moisture out of the air. Then if the call for cooling is still there after that 2-minute 50% airflow, 5-minute 82% airflow, if the call for cool is still there, it'll go ahead and ramp up to 100% airflow until the thermostat is satisfied. Once that thermostat is satisfied, it'll continue to run the fan for 60 seconds, and then it'll ramp it on down and shut it off. So this ramping operation, this what we call cooling on delay operation, this ramping operation really helps us control moisture and humidity in humid environments if you have it set on the B profile. Now, fellas, if you take a look at the install information, there's 4 different profiles. We've got one for humid, which we've shown you just right here as an example. We have another one for dry climates. We have another one for temperate climates, and so on. So take a look at the install information that comes with the equipment, and you'll see that there's 4 different profiles based on your humidity and based on your local environment. And so we recommend that you definitely set these up for your local environment, because it can really enhance the comfort for the homeowner, especially in humid conditions. And so if you live in the southern United States, Florida, South Texas, along the Gulf Coast here where I live in Mobile, Alabama, for instance, we use this B profile all the time on variable speed air handlers because it really helps yank that moisture out of the air compared to a standard air handler, in the cooling mode of operation. So whoever had that great question, that's what the delay jumper's for. And we definitely recommend you utilize that for enhanced comfort for your customer. But any questions or comments on that delay jumper?
No, we're good.
Okay, good. Fellas, so we've talked about the jumpers, the airflow jumpers. Let's get back to the board. Right next to the airflow jumpers, we have a humidistat yes/no jumper. And kind of remember where that is. Now, what we do is we ship it from the factory in the no configuration. But double check that. If you want to use that humidistat, yes, no, what it will do, it will allow you to enable the humidifier if you have a humidifier in the wintertime, but it also allows cooling dehumidification. So if you want to use that function, that jumper has to be in the yes position, and we're going to show you how it's going to enable that purple wire down below a little bit later on the low voltage wiring. But if you want to utilize that, put that on the yes position, and then, or if you don't want to use it, leave it on no. But either way, this is really, really important. Write this down. If that jumper is in the yes position, let me say it one more time. If the jumper is in the yes position, but you do not utilize the purple wire down below, which we'll talk about in a little bit, a humidistat function, what's going to happen in the cooling mode of operation, if that jumper is in the yes position, in the cooling mode of operation, if you have it in the yes position, but you don't have a humidistat hooked up on the purple wire, you will never go above 80% airflow. Yeah. So this cooling dehumidification function allows you to use a humidistat on that purple wire that we'll talk about in a little bit. If this humidistat is in this jumper's in the yes position, it will never allow the fan to go above 80% airflow in the cooling mode if you don't have a humidistat hooked up to that purple wire. If you don't want to use that function, make sure that during your setup and commissioning that you always make sure that humidistat jumper is in the no position if you don't want to utilize that. Otherwise, it's going to reduce your cooling airflow by 20% if it's in the yes position and nothing's hooked up to that purple wire.
Why? Is that why? Just because it?
So from a troubleshooting standpoint, if you've ever been out on our equipment, daggone, I got my airflow set up for 2.5 tons of airflow at 1,000 CFM, but golly, I'm only blowing 800 CFM, and I don't know what's wrong. It must be a bad board. No, you better double check that humidistat jumper. Make sure it's in the no position if you don't want to use it. Any questions on that?
Yeah, how is that related to the UM on the green terminal block there? Is it any relation there?
I didn't hear the question. One more time.
How is that jumper related to the UM on the green terminal block at all?
Yes, absolutely. And so if you want to use a humidistat, yes, no, you put it on yes. And then down below on our low voltage wiring that we're going to talk about a little bit, there's a purple wire down there that you'll use for a humidistat input. But that humidistat input is also being used as a cooling dehumidistat.
The problems with blower motors.
Well, it's supposed to be default, but no, so the factory is screwing up. Good morning.
No, whatever. Whatever.
So good. So the point is, on the board, we give you some really cool functions for humidistat and dehumidification function. If you want to use it, put that on yes, but if you don't want to use it, put it on no.
What if that jumper wasn't existed at all? If it wasn't there, what would happen? Like,
That's a really good question. I believe it defaults to no.
No. Yeah.
So if it's missing, I think it's automatically no. It's just that when you put it on yes, it enables some things. But if the jumper's missing, I think it defaults to no.
And just to clarify, Joel, this control board is only available on the AVCs and AVVs, correct?
Yeah, this is our variable speed air handler control board.
On the AEs, it'll be similar, but not all those functions.
The variable speed.
Okay.
The one that controls the speed of the board.
Yeah. So this is our variable speed air handler control board. Now, if you have like an AE air handler, it won't have a board in there.
Right.
It's not controlled.
But yeah, good question. Now, fellas, right next to that Humestat jumper, there's an AC HP or AC and heat pump jumper. Now, please remember, this is really important, that when you commission the air handler, make sure it's on AC, because I believe we ship them from the factory on AC. But if it happens to be on the HP, if the jumper happens to be on HP, you're telling the board it's on a heat pump, and it's going to be looking for an O signal for cooling mode. And it can throw a fault. You'll say, oh, God, why am I getting an O signal fault? I don't even have a heat pump on here. Well, double check that jumper, because if you're going to use it on AC only operation, make sure that jumper is on AC, not HP. So in our example, in the training we're doing today, you're always going to want to double check that jumper to make sure it's AC for air conditioning only application, right?
Yep.
As we move down the board, we have a model ID plug. And what that model ID plug does, it tells the board what size the air handler is. So you'll notice that you've got different jumpers on this little model ID plug, just little wire jumpers. It's nothing fancy. It's just some jumpers on this plug. And that configures the board for the size of the air handler. And so if you have a replacement board, we always recommend take the model ID plug off the old board, stick it on the new replacement board, and then when you power it up, it automatically knows it's on a like a 3-ton air handler or whatever. And the reason we do this is so now you don't have 25 different boards, for different air handlers. You have one board, and then the model ID plug configures that board for the tonnage or the size of the air handler. So make sure that model ID plug's there, and all that. Okay, at the very bottom of the board on the left-hand side, we have a 3-amp fuse for 24-volt safety. And this fuses all the 24-volt components on the board, and it protects the board. Right next to that 3-amp fuse, you're going to have a harness that's going to go down to your blower and your heat strips. And again, the harnesses are off the board, but as you take a look at it, this is all going to be wired in from the factory. You'll have this harness going down to the blower motor and to the heat strip and all that kind of stuff. And so that'll tie on in. Right next to that, you're going to have your thermostat connections. Now, we're going to take those thermostat connections and blow them up here in a minute or two and talk about them individually, each individual terminal. But please remember, guys, on an air handler, on our variable speed air handler, we've got a harness plugged on here, and we give you about a 6 or 8 inch wire pigtails. So that's how you're going to make up your low voltage wiring for your thermostat connections, your low voltage connections, and so on, is going to be on with pigtails with those. So let's go ahead and blow that up real quick, those thermostat connections, and talk about each connection, each wire, each terminal individually. And again, we don't have the wires on there, but we're going to talk about the color of the wire that's on there and how you'll hook that up for your thermostat. So starting on the left-hand side, our terminal is our 24-volt hot terminal, and that's going to be fused. And so you'll have a red wire coming off there. That's for your 24-volt hot. Right next to him, you've got your G terminal. It's a green wire, and that's going to be your fan on command. Right next to that is your Y/Y2. Now, what this really is, if you have 24 volts on this pin, and this is how I like you guys thinking about variable speed air handlers. If I have 24 volts on that Y/Y2 pin, it's going to drive my air handler to 100% airflow wherever I have my cooling airflow and my adjust airflow jumpers. So remember we talked about your cool and adjust jumper. You're configuring your Y/Y2 airflow. Well, that's it right here. So if I've had 24 volts on this Y/Y2 terminal, it's a yellow wire. It's going to drive the air handler to 100% airflow. Now, please remember the connection to Y for a single stage cooling. So in other words, you don't want to use Y1 for single stage cooling. You want to use Y/Y2, which is our 100% airflow, if I've got a single stage unit setting outside. Any questions or comments on that?
Nope.
Okay. Now, if you had a two-stage unit outside, Y1, the Y1 input, and there's if I've got, and it's a yellow and black wire. If I have a Y1 input, what it's gonna do, the board's gonna take a look at that Y1 input, and it's going to say, oh, gee whiz, I'm calling for first stage, and it's going to automatically drive the cooling airflow to 65% airflow, because that matches our 65% capacity on our two-stage equipment out there. So if you do have a two-stage piece of equipment, Y1, yellow and black wire goes here, and then Y/Y2, which is a yellow wire, goes on the one we just talked about. W2 is our second stage heating if you have a two-stage heat strip. W2 is our second stage heating, and that's typically going to be a brown wire. Those are brown. That's the brown wire for second stage heating. W1 is our first stage heating input. And remember, guys, if you've got a real small heater, if you have like a 5 kW heater, it's a single stage heater. And I think the 8 kW is a single stage heater too. You'll have that white wire for your W1 input for your heat strip. Now, if you have more than one heat strip stage, that W2 will be a brown wire. The W1 will be your first stage heating. The O terminal is going to be used on heat pump systems only. Now watch this. That jumper up above that we talked about, that AC/HP jumper on the control board, when it's set to AC, it basically ignores that orange wire. And so that's why it's important. You know, you're going to just cap that wire off anyway if it's a straight cooling. You know, you're not even going to use it because that's going to be used on heat pump only application to energize the reversing valve in the cooling mode. But if you're on a straight cooling system, just cap off that O wire, that orange wire, and remember to double check to make sure that that jumper up above is on AC. That way the board's not looking for an O input for cooling mode. So it's important that you do that, because on our variable speed air handlers, if you don't have a heat pump, if it's not hooked up to a heat pump, then this thing needs to know it's on a straight cooling unit. And so the board is smart enough to know if it's on a heat pump once you configure that. But O terminal or the orange wire is strictly used for heat pump only, and you're going to disable it when you go to straight cooling application. Any questions or comments on any of that stuff so far?
Nope, I'm good.
Everybody good? All right, guys, here's that purple wire, that Hume wire. Now remember that Hume will dehumidify in the cooling mode, or it will also humidify in the heating mode. So what it is a purple wire that they have on here. That purple wire goes to a humidistat. And that humidistat in the heating mode of operation will bring a humidifier on, but also that humidistat in the cooling mode will reduce the airflow in the cooling mode for extra dehumidification, you know, for ultimate comfort. So if you want to utilize this Hume terminal, this purple wire, you're going to have to hook a humidistat between Hume and R terminal. You'll just grab 24 volt hot, go through a humidistat and hook it up to Hume. And then up above, that jumper is going to have to be in the yes position on that Hume, yes, no. You're going to have that in the yes position. If you don't want to use this, if you don't want to use this circuit, you don't have to. Leave it alone. You know, if you no humidifier, you don't care about extra dehumidification in the cooling mode, make double, triple sure that that Hume jumper up above is in the no position, Otherwise, you risk having only 80% of your cooling airflow if it's in the yes position, but nothing is hooked up to this purple wire. Any questions or comments on how you'd utilize that for extra dehumidification and that jumper configuration?
Hey, Joe, I want to ask just a quick question here. So in some cases, you know, with variable speed, you know, with the system, if they wanted to hook up, let's say, a Honeywell or an Aprilaire thermostat that has dehumidification or humidification control built in, do they have to do anything with that purple wire because it's technically a humidity controlled thermostat, but it's not really it's not really a humidistat, but it does control it?
Man, I'm going to tell you, you talk about an absolutely excellent question. So there's three methods. There's three methods of controlling humidity in a space. One of them, you can do it thermostatically, like you're describing, Ty. Thermostatically, you just basically let the thermostat make an intelligent decision on when it goes into the cooling mode, it's going to allow a little bit of overcooling to bring the humidity down. So you can do that. So you can let the thermostat dehumidify by letting it call for cooling, or to extend the cooling time to get a little more humidity out at the risk of overshooting the space temperature a little bit. Another way of doing it is anytime you have a call for cool, you slow the fan down. And so when you slow the fan down, that gives you a colder evaporator, which takes more moisture out during that cooling call. And then, of course, the third methodology is what we call reheat or desiccant technology, to where you're actually reheating the air, or you're doing something with a drying agent to dehumidify the air. But the two most common methods are let the thermostat do it or slow the fan down. So this method right here with the purple wire is actually a slow the fan down method with a humidistat. But if you don't want to utilize that, to your good question, to your excellent question, I might add, if you've got a thermostat that has the capability of doing that, then do it at the thermostat level and make sure that this purple wire is just capped off, and make sure that humidistat jumper is in the no position, and then let the thermostat do it. So that's a good way to do it as well.
So it'll satisfy on the humidity and that temperature?
Right.
Yeah.
Right.
So I guess in summary, the way to think about this Hume circuit right here for cooling, it's a fan slow them down circuit. Whereas your thermostat doesn't slow the fan down, it just extends the cooling runtime to get a little extra moisture out during the call for cool.
And they're like, I think this thermostat's broke. But it's not. It's because it's hooked up with that. They wired it in with the purple.
Now, if you're going to utilize, I kind of heard the question or the comment in the background. If you're going to utilize a thermostat with, say, a humidifier function, and you hook the purple wire up to it, then you're going to have to make sure that that thermostat configuration is for humidifier, not dehumidification, to this purple wire, because this purple wire, it uses a set of contacts that close on a drop of humidity and open on a rise of humidity, which is a humidistat. A dehumidistat is exactly the opposite function. So if you are going to use this purple wire on a thermostat that has humidifier function, make sure it's on humidifier function. In other words, the contacts close on a drop of humidity and open on a rise of humidity. And then basically your thermostat humidistat function would be slowing the fan down. So you could configure a thermostat, if it's so equipped, to utilize that purple wire as kind of the final thought on that.
Just a little more complicated.
Let's just mess it up.
A lot of stuff to remember. Listen, if you guys, let's just put it this way. If you guys run into a special application, please call me and we'll walk through some different scenarios that may work well for you for extra dehumidification strategies in your market there. Okay.
Thanks, sir.
Okay, good. Any other good questions or comments on that?
Yeah.
Nope.
All right. Well, fellas, that last terminal is a 24-volt common terminal, and that's our blue wire, and that's, we're going to make connection to the outdoor unit, for our Y terminal and our Y/Y2, and our C terminal goes outside, for our single stage cooling outside. So you just have 2 wires going outside. So please remember to go ahead and make that blue wire, that common purple wire, going out to your single stage unit as well. Well, fellas, at this time, that pretty much concludes our training session on our variable speed air handler low voltage review and jumper setup. Let's go ahead and open the floor up if there's any final questions or comments.
Does anybody have any questions at all?
Who's got the test questions? Who's got the test?
Who's got the test questions?
Well, we went through this, you gotta pass a test.
We gotta have a couple classes first, and we'll do a test on everything.
Oh, okay.
So what is the YouTube channel for this?
Okay, what we're going to do is, Ty, I think I've got your,
Ty, I sent that to you. You've got it in your email, Ty.
Okay, I'll forward it to Rob.
Yeah, it's our training catalog. And Joe, you want to just kind of talk about that training catalog that you put together and what all's in there and what a great resource that is?
Sure. So what Tony just sent you is a direct link to our YouTube training channel. I've got about 30 videos out there, and this will be out there, by the way, later on today. And so what it is, you just click on that link and you'll go out there, and there's all kinds of subjects and videos that we've recorded a lot of times with local companies like yourself, doing training sessions. And so by all means, utilize that. It's like Tony said, it's a great resource. I think this is actually going to constitute, today's video will constitute 32 videos out there now, and it's just open format. Go out there and look at it. As long as you've got the link, you can click in and go to the YouTube training channel, and just a lot of cool stuff out there to look at.
Yeah, and there's testing and there's all kinds of stuff on Navigator training. I mean,
Yeah, now if you go to Navigator and you go to the Ducted Academy website, you'll find that there's all kinds of training resources out there as well. And like you said, Ty, some testing and some quizzes and stuff like that. There's lots of good information out there. And then, of course, this type of training we're doing this morning, if this is something you guys like, please get with Tony and we'll set up again to do more training. It's an honor and a privilege to train with you.
Yeah, we want to do something maybe once a month or every couple of weeks or something like that. Yeah, update, just to refresher stuff.
That sounds real good.
We should probably, go ahead and schedule that now, when we complete one, schedule one, and then we'll always have one in the pipeline. So you guys want to do that now, or Ty, do you want to call me with it?
3 weeks from today.
All right, so Rob's saying 3 weeks from today.
Tell you what, guys, let me go ahead and stop the recording real quick. And thank you for training with us this morning.
Let me look here at the calendar.